Chapter 6, Exercise 5. In China, 4-year-olds average 3 hours a day unsupervised. Most unsupervised children live in rural areas considered safe. Suppose that standard deviation is 1.5 hours and the amount of time spent alone is normally distributed. We randomly surveyed one Chinese 4-year-old living in rural areas. We are interested in the amount of the time the child spends alone per day. In words, define the random variable x. So it looks like x is going to be the number of hours that a 4-year-old Chinese spends unsupervised. Okay, our random variable x can be described in this particular distribution as a normal distribution because this is normally distributed. The mean is 3 hours and the standard deviation is 1.5 hours. The next question, find the probability that a child spends less than 1 hour per day unsupervised. So whether they ask you to sketch a graph or not, I think it's always the best approach if you can sketch a graph for a normally distributed probability. We have the mean sitting right in the middle, and then they want to know the probability. So probability is equivalent to finding the area that we're looking at spending less than 1 hour per day. So I would shade in the area to the left of this number 1, which is to the left of the mean number 3. Our notation for this will be the probability that our random variable is less than 1. And you can just type the answer in after you punch into the calculator, but I would prefer if you can note the calculator command that you'll be using. So for normal distributions, we'll use normal CDF. We have the low and the high. The low in this case is to the left of -1, where the graph doesn't touch the x-axis. And so technically this is -infinity. And the best way to denote -infinity in the calculator is -1 times 10 to the 99th power. That's a very large negative number. Our high is 1, so this is a low high. Our mean is 3, our standard deviation is 1.5. So that is what we'll put into our calculator. Our calculator has the normal CDF in the second in bars. That's our distributions. We're going to select the number 2 or scroll down to number 2 until you see normal CDF. The negative sign for -infinity can be found here. So make sure you distinguish that from this negative sign. So this is negative, and then we have a 1. And then the e is the second function right above the comma. That's e to the 99th power. I'll hit comma. And then we have a 1, comma 3, and then a 1.5. And so if we press enter, we get 0.0912. So that's our probability. Part D, they're looking for the percent of children spend over 10 hours a day unsupervised. So this is almost the same thing as solving for the probability. Again, we want to draw things out to get a visual of what's going on. We have the mean and then we have 10 over here, and then we want to know the probability of the percent of children that spends over 10 hours a week. Notation is very similar, and the calculator command is also very similar. Which is a normal CDF. This time the low is a 10 and the high goes to positive infinity. Same mean and standard deviation. So if we have a lot of things in common from our previous command, we can recycle our previous command by saying second and enter. And all you have to do is you move your cursor left and right to control where you want to be. Now our first argument from our last entry was a negative 1e to the 99. So here I want to insert a 10. So I'm going to press second function and insert, type in the number 10 and then a comma. And my next argument is positive infinity, so I have a negative infinity there. I want to take that negative sign out by hitting delete. And let's move the cursor. The third argument for a normal CDF is your mean, and standard, and the last one standard deviation. So I have this extra one that I want to get rid of, and one more delete for the comma. So you can just retype everything over if you want, but if there's any ways to find shortcuts, this might be one way to do it. And I'll press enter to get a result. Now, our result is not 1.532 and then stop there. This would be incorrect because our probabilities are always between 0 and 1, and clearly this is bigger than 1. That e to the negative 6 says that you get 1.532 times 10 to the negative 6 power. In effect, that takes your decimal point and moves to the left by 6 places. So that would generate 5 extra zeros and then a 1532. Now this is a very small number, and sometimes it is denoted by a 0 plus, sometimes it's denoted by 0.000, but be clear that this is not equal to 0, because saying you have a probability of 0 says this will never happen, this is impossible, but it's not in this case. A very small probability does not mean it's never going to happen. So there's a very small percentage. As a percent, I would probably move this decimal place another 2 units or 2 places. So that would make 3 zeros. And that is clearly less than 1%. 1/10, hundredths, thousandths, it's less than 1/1000th of a percent. So that is our answer for part D. In part E, they're looking for 70% of the children spend at least how long per day unsupervised. So what we want to do is we want to shade in a 70% that spends at least how long unsupervised. Now this word at least often refers to being greater than or equal to. We might have seen this phrase in the binomial distribution. And so what we're looking for is this marker here, and 70% of the population would fall in this bigger than or equal to this number category. Remember that if you're not looking for the probability but you're looking for the actual score, you're going to use the inverse norm, and then you're going to need the area to the left. So if this is 70%, to the right of that point, the area to the left is 30%. And so that's what we're going to use. Our notation that's needed here is a probability that your x value, your shaded region, is bigger than some number that we're going to look for, and this is supposed to be 70% or 0.7. Now to find this number, we will use the calculator's inverse norm function, which looks for the area to the left, comma the mean, comma the standard deviation. So the area to the left, remember, is 0.3. Inverse norm in our calculator can be found using the second function in vars. The third option is the inverse norm. The area to the left is 0.3. The mean is 3. The standard deviation is 1.5. So this is going to give us a 2.21 hours. It's less than 3, which means this does make sense. 2.21 hours. So that's it for problem number 5. Good luck with your homework.